John with Electro-Matic Siemens Tech Support in Farmington Hills, Michigan, and we're going to go over some programming basics for 300 series PLC in Step 7 version 5.5. We're talking to this PLC via Ethernet, and what we're going to cover is basically the data structure of the PLC, how FBs work, how FCs work. We're going to load a program to the PLC, do some online-offline comparison for the whole program, as well as individual ladder, as well as individual functions in the ladder editor. And also, we will change one of the functions to show how the online-offline compare shows a difference in version 5.5. So let's get started. The first thing I'm going to do here is I'm going to open my symbol table editor, and I'm going to create a symbol for the clock byte of the PLC. So the symbol table editor is here. If in the project tree, you click on the program folder for the PLC you're working on, there's a symbol table listed here. Double click on that and you'll get the symbol table editor. So I'm going to add one for the clock byte. I'm going to save this. Okay, so now my clock byte has the symbol clock byte. What that means is anytime I reference that in any other portion of my program, then instead of it being MB0, it'll be both MB0 and it'll have the symbolic name clock byte. This is a VAT. I can also do this in a piece of ladder logic or anything. It'll always have that new symbol now. So I'm going to close this, save my changes. All right, now the next thing we're going to do is create an FB. So what an FB is it's a function block, and a function block has some local data that it can store from scan to scan, as opposed to a function call, which does not have any local data that it stores from scan to scan. So I'm going to open up my function block, and if I click here and drag down, I'll open up the interface for the block. I'll add an input, which is just clock, and then it'll be a byte. And then I'll make a stat, and I'll make that clock multiple, and I'll make that an int. Okay, so now what I'm going to do is, the reason I did this is because this is a stat. What that means is this data is saved in this function block that's associated with this data block, and it's saved from scan to scan. So I can do things like have a bit or a number that is changed and analyzed every scan, and maybe there's a certain event that I want that particular bit or function to be true for. When that's the case, I can have that saved locally as opposed to having it saved globally, either to like the memory space of the PLC or the or another data block or something like that. So what I'm going to do here is I'm just going to do some quick math on the clock byte. Okay, so I'm going to make that a static 15. So now what this is going to do okay. The reason why that happened is because this is the multiplier for an integer data type, and this is a byte. So I've already gone through an option that allows me to do this kind of a thing. Normally you wouldn't be able to do that, but I've turned off type check of address. So now it will implicitly define these data types. Otherwise, this data type would need to be an integer data type because this is a multiply integer block. That's just an aside. So now I have my clock byte. It's going to be multiplied by 15, and it's going to be stored in the clock multiple. And then I can do this too. I can add a network, and I can put in a comparator. And I'll put my clock multiple. Actually, here, let me kind of doing this on the fly. So this will be more useful. Okay, so now I'll have a local bool that will get set when this is true and reset when that's true. And I suppose here, let me do this. Now I'll create a pulse memory bit, so this will only happen once as opposed to happening every scan. So just put in this. Actually, I'll make this an array of bools. Okay, so now I just have two separate bits. So we'll use Okay, so I really want two different bits because there is going to be one scan. The, the scan right after this becomes false, that would cause the use of one bit to cause this never to actually fire. So I have two bits, and because I'm using function block, I can do this. I can just put some pulse memory bits inside of the static area. You can't do that inside the temp area. If you try to do it in the temp area, the nature of the temp area will cause this pulse to constantly go off. That's because the temp area is cleared from scan to scan. Because the static area is not, I can put this information in the static area. It's retained from scan to scan, so these rising edge detectors will work properly. All right, so now I just have some function. It's going to do some multiplication on my clock byte. It's going to store it to a local integer, do some comparisons, and then set some bits. So I'm going to save this. I'm going to close this down. Now I'm going to insert an FC. So again, an FC is a function call, and the difference between a function call and a function block is a function call doesn't have any local data. So specifically what that means is I can have an input. So I can create an input for the clock byte. But now there's no static area, so I can't store any values locally. Additionally, I can't have any edge detection locally. All of that would have to be done in the memory space of the PLC or in a separate DB that isn't necessarily assigned to this FC. So let me just do some multiplication on this clock again. We'll do 100 for this one. So I don't have a place to put this really. I'm going to put it in memory word 100. It needs to be a word because the result will be an integer. But this is just a static memory location. So I'm going to save this, and this doesn't have any symbolic information tied to it right now. So what I can do is I can insert a symbol for this. So if I insert a symbol, I'll call this FC clock multiple. I'm going to add it to my symbols. I'm going to apply, click OK, close this. So now it has this symbolic name. I'm going to save this. And when I go to my symbol table, we're going to find that it's been added. Right here. FC clock multiple at MW100. So what I did is I created a symbolic reference for that memory space, which is basically there for the user. Okay, so now I'm going to call my FB and my FC and OB1, steps 6 and 7 here. And the reason they're two different steps is because my FB is going to require a data block. So if I put this in and just type FB1. So I've called my function block, but now I need a data block for it. So I can type in any data block that's not being used. I'll say DB1. There are no data blocks in my program, so it's available. When I hit enter, it'll say it doesn't exist. Do you want to generate it? I'll say yes. All right, and then clock is just going to be the clock byte of the PLC. So now FB1 has its data being stored from scan to scan in this instance data block DB1. Now I'm going to add another network that has FC1. And notice that FC1 doesn't require a data block because it doesn't store its data from scan to scan. Put that here. Okay, so now I'm going to save this, close this out, and now I'm going to download everything to the PLC. So if I click on the station name and the download button, it's going to give me a warning. It's fine. It will download the entire contents to the PLC. So I'm just going to say yes to all. It's in stop. Do I want to start it? Yes. Okay, so now what I've done is I've copied all of my programs, my hardware configuration, everything. I've copied it to the PLC. So what I'm going to do is I'll add my variables to the VAT and then view it here. So let's do this because I want to see the symbols as well. And there's actually one last thing I want to see. see how this DB1 got created? This got created when I referenced that for FB1 and OB1. So this DB1, no. We're going to view, data view. Okay, and so now what I want is my symbol editor, my variable table, and I want this here. Do some sizing. Okay. Okay, so now I can kind of see where everything's at. So what I'll do is I'll add all of my different symbols to this. So MW100, and then let's do db1.dbx 4.0, then db1.dbx 4.1, and then db1.dbw2. All right. So now this will look at the data in db1, which is the instance data block of FB1, holding its data from scan to scan. And it will look at the FC clock multiple, which is held in MW1, the byte memory area of the PLC. So now we can go online with this and see that everything is changing. So here we are. When that value is greater or less than 1,000, I get my true and false flags, and I can see that the PLC is working. If I put the PLC in stop mode, we see that everything stops. I can reset the memory, put it into run, and it goes. Okay, so next what we'll do is we will go online with the PLC and kind of do an online-offline comparison. So online-offline compare, let's see here, blocks. You right-click on the blocks folder, go to compare blocks, online-offline. We'll do a code comparison. Compare. Okay. So it says OB86 only exists in path 2 online, and OB87 only exists in path 2 online, and DB1 timestamps are identical. Okay, so what this means, OB86 and 87, these are rack fault and network fault OBs. What they do is they keep the PLC running in case of a disconnect from remote I/O or local I/O. But they're only in the PLC. They're not in my program because they were probably there from like the last project. DB1, it says timestamps are identical. What this means is, the values in DB1 are constantly changing. So the DB has different values, but the timestamps are identical. So all of like the variables and everything will match. It just means that the values in the online and offline version of the DB are different, but everything else is the same. So this is showing me that my online and offline project are the same. If I want to, I can click on the PLC. I can go online. I can open this up, and I can see all of my SFBs, FCs, OBs, and FBs and DBs and FCs. So I can delete these right now because I don't really want those there. I didn't put them there. They're a holdover from my last project. So now I've deleted those. I'll go offline now, and I'll do the same thing. All right, so now it just gives me the DB1 timestamps are identical. Okay, so now what I'm going to do is I'm going to make a change to OB1, and I'm going to save it offline, but I won't save it online. I won't load it, and I will execute a code comparison, and you can see that there are differences online and offline. Oh, but if I look here, it says I should go online with my FB, so I'm going to do that in the ladder editor first. So let's do that real quick. All right, so if I want to view this block as it's running on the PLC, I click these glasses. This green bar at the bottom will fill very quickly, shows me that my program is running, and I can see all of my live values. So I'll go offline, and now I'm going to make a change. Let's say that I want to add something, and if this, let's do something simple. We'll just add a value to the clock byte. It's a little bit weird if you use different data type. Let's save this to W12. W102. Okay, so now my online and offline programs are different. So if I do an online and offline comparison, it says path 1 contains a newer version and timestamps are identical. So path 1 is my offline program, path 2 is my online program. So basically, it's telling me that FB1 is different. All right, so if I wanted to, I could go to. Now this opens up the online and offline editor, and I see that online I have this structure, and offline I have this structure. So everything is the same down to here. So what I could do is I could click on my offline copy, download it, and now update this. And the comparison shows that it's the same now. The online view doesn't update. I don't think there's like a right-click update type thing. Yeah, the online block is different from the associated block in the CP. Do you want to close a block and then open it? Yes. Okay, so here we are. So now I've got everything matching, and if I actually could have just updated that, but if I compare the blocks again, it shows me that I only have timestamp differences in my DV. Okay, so that concludes this video. The list here will be in the notes. Thanks for watching.